So when I grab a piece of blue styrofoam out of Home Depot and slice it up into sheets, or if I'm lazy and just order it from Aircraft Spruce. And by the way, if you order this blue styrofoam from Aircraft Spruce, now you're buying this stuff from a place called Aircraft Spruce and Specialty, not for structural use in aircraft. It's like, well, what the hell else are you going to use it for? A seat back? Maybe, I guess so. Darn well, people are going to use this in composite construction. Now, why would somebody label this material as not for structural use? And I had to stop and think about that. And I go, what is a structural material? Is the Airex foam a structural material because it's designed and made for aircraft? Does that make it structural? The blue stuff that Rutan uses in the core of his wings, it's a blue styrofoam. It's different than this stuff. It's manufactured differently, but they're both polystyrenes. Is this structural because Burt Rutan says, hey, you can use it in an aircraft, you can hotwire your cores out of this? Well, in his case, it's just a core. It doesn't lend any strength to the aircraft. It's just there for forming the fiberglass on. So does that make it non-structural? No. There's loads that go in the foam. It's just that the loads that go in the foam are inconsequential. Most of the loads are out in the skins. So does that make this a non-structural material? No. And actually, a good definition of a structural material is any material that will carry the loads for which it is intended to carry and provides the other durability and handling characteristics that you need in the aircraft. This paper towel here, paper towel can be structural material. I don't know how you'd actually use it on an aircraft, but there's nothing saying that any material can't be a structural material, provided you don't put loads on it that it's not capable of carrying. This styrofoam has no compressive strength compared to PVC foams. PVC foams have 2, 3, 4 times the amount of compressive strength. But what if I don't put compressive loads in this foam? What if I'm using it differently? What if it's only in bending? Oh, I got compression on one side, tension on the other, but how much is it going to bend? What are the actual loads in the foam? And rather than just throwing stuff out and say, you can't use that because it's not structural, it might back you into a design corner. This is 2 pounds per cubic foot. It's really light. Airex foam, 3 pounds to 6 pounds per cubic foot. Well, I can save weight here. And if we're down to 1 ounce equals 8 3/4 pounds, how much weight goes into this foam core? A big deal. How much weight goes into this foam? Big deal. If you can step away from 3 pound and go to 2 pound for the same thickness and get the job done, you're on to money there. So when you're pushing right to the limit on trying to get a high strength to weight ratio aircraft, you can't throw anything out as saying that's not a structural material or you can't put that on an aircraft. Everything has to be fair game. Whether it's a piece of fabric my wife's got laying around for her sewing, or it's the most expensive Textream spread toe carbon fiber woven fabric. It's all fair game. You have to be a smart designer though, and not use it in a way that is going to apply more loads to it than it can carry. Simple as that. And as an aside, because somebody asked a question about the ribs of my aircraft are actually this blue foam, some of them, and they have basswood cap strips, top and bottom, and some of them have carbon fiber between the cap strip and the foam. And in that case, it's actually the carbon fiber that's the rib, and the cap strips are just for having a good surface to attach the fabric to, and the foam is just a former for making the rib. The ones that have the basswood without the carbon fiber, in that case, the basswood is the rib and the foam is the former. And a question came up of, I wouldn't use that foam for ribs. It has no compressive strength. It's not structural. And I thought, I've seen this used in the Icarus ultralight hang glider, And on the Easy Riser, you know, they used blue foam, 1-inch wide. They put some, I think they used spruce top and bottom, might have been something else, and they actually put some screws into that wood. And that was their ribs. Many of those, hundreds of those were built. They flew fine for years and years and years. So, but what do I know about this material? I used it on my original wing. Up for nose ribs, worked fine for that. But how strong is this stuff really? And I went looking around for data, and there wasn't much data. And somebody online, one of the many great gatherers of data, said, hey, somebody at the Sailplane Forum actually presented a parametric analysis of different rib manufacturing methods and what they were really like in terms of their true strength. And they made 1/4-inch square spruce built up ribs, just like you would see in almost any home-built aircraft. Very traditional, you know, with the little gussets and all that, a gazillion parts. And speaking of a gazillion parts, this rib here that had the right strength to weight ratio, each rib had about 47 parts in it. So it was a nightmare to make these too. That was another one of the problems. But anyway, I digress. And they, in that test, they also did 1/4-inch thick plywood sawn ribs that are used like in the Cherokee sailplane, where you have a flat sheet of plywood and you cut out a rib shape and then cut lightning holes in it and so forth. And then they made ribs out of this blue foam. I think they used pink too, but they're both the same. It's just different color. And they had spruce cap strips on them. Now, those were 1-inch wide, and the cap strips were the same width as the foam, although my cap strips are actually wider than the foam. And here's the surprising result. I was shocked. I'm an engineer. I've been doing this a long time, and the numbers surprised me. The foam ribs with the wood cap strips were 3 times stronger than the 1/4-inch square built up traditional ribs that have been used for decades in powered aircraft. And they were almost twice as strong as the plywood cutout ribs. The plywood cutout ribs and the spruce ribs would fail in buckling way before the wood cap strip would peel loose of the foam and buckle itself. In fact, that was the failing mode on these. The wood cap strip would literally buckle up like this and then snap, and the rib would fail. But the foam ribs with wood cap strips, massively strong. Very high strength to weight ratio, unconventional. You know, I'm not going to put them in an airplane that goes 200 miles an hour, but my glider's going to fly like 75 miles an hour. It's not going to go that fast. And now I'm very happy to say that I have actual real data where somebody went and made a bunch of ribs and tested them to failure and said, what do we really know? Just because a particular rib design has been used for decades doesn't mean it's the best answer. There's always new materials and new ways of doing things. And if you don't know, build it and test it and find out. Most of the time you get junk and you go, well, that doesn't work. Like on these, 13 times. But you do eventually get there and you go, oh, that's pretty cool. And then you spread the news out to everybody else and go, you can make ribs this way. It's pretty cool. And they'll be strong and they'll do the job for you. So there's a lot of that.